Greetings, mathematicians, and welcome to Investigation 3.3. We're going to learn how to use prime factorization to find the greatest common factor. Go ahead, pause the video, write down the focus question, please. How can I use prime factorization to find the greatest common factor? All right, now, good news is that this process is very, very similar to using prime factorization to find the least common multiple. Even better news, it's shorter. Okay, so let's go ahead and write down a few examples. So remember from the least common multiple video, we talked about finding the factors that both numbers had in common and finding the things that were unique, finding the factors that were unique about each number. Well, greatest common factor, like I said, finding the greatest common factor using prime factorization is actually shorter than finding the LCM. So with greatest common factor, we can actually stop when we find what things they have in common. What prime factors do these numbers have in common? So let's go ahead and prime factorize. Let's find the prime factorization for each of these numbers here. So 57, it's an odd number. So what's the smallest number that goes into 57 that is not 1? 2 does not work. Does 3 work? Yes, it does. So I write 3 on the left side, and 3 times what gives me 57? 3 times 19. Is 19 prime? Can I break it down further? I can't, so 19 is where we end. So that's the prime factorization for 57. Let's do the same thing for 27. The smallest prime number besides 1 that goes into 27 is 3. I know that 3 times 9 gives me 27. Is 9 prime? Can I break it down even further? It's not. I can break it down into 3 times 3. Now remember, the process is shorter. We stop after we find what prime factors do they have in common. What do they have in common here? Well, I see that they both have 1, 3. So I write that down in my list, and that's it. That's it. That's all you have to do. Write down what they have in common. I mean, in this case, they only had one thing in common, so we write down that one thing, and that is the greatest common factor. Let's take a look at another example, this time with some more things in common. Let's take a look at this problem. Find the GCF, the greatest common factor, of 24 and 48. Remember, the process stays the same. Let's prime factorize. Let's find the prime factorization of 24 and 48. So 24, it's even. So I know that 2 is automatically the smallest prime number besides 1 that goes in. And we know that 2 times 12 gives us 24. Is 12 prime? No, it is not. So I can break it down further. Again, it's even, so I know that 2 is the smallest prime number that goes in. And 2 times 6 is 12. Is 6 prime? No, it's not. So I can break it down even further into 2 times 3. Excellent. All right, let's do the same thing for 48. Again, it's even, so automatically I know 2 is going to be the number right on the left. And 2 times 24 is going to give me 48. Is 24 prime? No, it's not. So I can break it down. It's even. So again, 2 is the smallest prime number other than 1. 2 times 12 is 24. Is 12 prime? No, it is not. The smallest prime number that goes into 12 is 2. It's even, right? Hey, this is starting to look familiar, isn't it? 2 times 6 is 12. 6 is not prime. I can break it down once more into 2 and 3. Okay, remember, greatest common factor. We are looking for the prime factors they have in common. So, I'm going to take a look. There's a 2. There's another 2, right? So those are what they have in common. It looks like they have another pair of 2's in common. And then they also have a third pair of 2's in common. So when I write my list, I'm going to write down 3 2's. Right, so there's this pair of 2's, this pair of 2's, and then finally this third pair of 2's. That's why I have, whoops, I wrote down a 3. That's supposed to be a 2. That's why I have 3 2's written down here. Okay? All right, let me erase some of this so that way it's not as messy. All right, but are we finished finding the things they have in common? No, we are not. There's one more thing. There's a pair of 3's. Now, because both of them have 1 3, I'm going to write down a single 3. Multiply all these together, and that is your greatest common factor. 2 times 2 times 2 times 3. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And there you have it. That's how you use prime factorization to find the greatest common factor.